Good morning, everyone. For this one, we're going to take a look at calculating values with mole ratios. So mole ratio just tells you the ratio in which compounds react and form in various reactions. And to do that, we have to have the balanced chemical equation. So here we know that for every 6 formula units of lead 2 oxide that reacts with oxygen gas, you need 1 mole of oxygen gas because having nothing there implies that it is a 1, and we will form 2 moles of lead oxide. That does not mean that every time it's going to be 6 moles, 1 mole, 2 moles, but it does mean no matter what, the ratio between all of these will reduce down to 6, 1, and 2. So for this part, we are looking at how many moles of lead oxide are produced from 1.25 moles of oxygen. So just like with mass and moles, we can do it one of 2 ways. We can start with 1.25 moles of oxygen gas. And we can look at our mole ratio here and multiply by that. And we know that we've got oxygen gas. And we want to get to Pb3O4. So we need to put moles of O2 on the bottom. And we said our ratio is going to be 1 mole of O2 to 2 moles of Pb3O4. Which means if we take 1.25 moles of oxygen and react it with lead 2 oxide here, we are going to end up with 2.5 moles of lead oxide here. You can also set up a proportion as always, because if we have 1.25 moles of O2, and we're looking for a number of moles of lead oxide created, we know that that ratio is going to be equal to the ratio of 1 mole of O2 to 2 moles of Pb3O4. If you solve for that ratio, you will also get 2.54. For the second one, we're looking at how many moles of oxygen must react with that many moles of lead oxide. Even though they're both are reactants this time, the process is just the same. And so if you start off with 8.75 moles of PbO, and you want to get to oxygen, you need to have moles of PbO down here, moles of oxygen up here. And we know that ratio is 6 moles of PbO to 1 mole of O2 because of our coefficients in the reaction. And so you just need to divide 8.75 by 6, and that will give you excuse me, 8.75 divided by 6, that will give you 1.46 moles of O2. Okay. If you do it with a ratio, it's the same thing, or a proportion, excuse me, it'll be the same thing. Okay. If you need to come up with the reaction, it's the same thing. We're just kind of going back a little bit to review that. And here it tells you everything. You just have to balance it, actually, because it tells you we've got nitric acid, HNO3. That'll be aqueous because it's an acid. It's reacting with magnesium hydroxide. We know that magnesium is going to be a +2 because it's in the second column. Hydroxide, OH is always -1. And so if magnesium is +2, OH is -1. We're going to need 2 hydroxides to make that a neutral compound. And that is going to be our base reacting with our acid, so that's also going to be aqueous. And we know that when acids and bases react, it forms water, H2O, which is a liquid, and an ionic salt with the other ions. So we used up the hydrogen from nitric acid, hydroxide from magnesium hydroxide. So we're left with the magnesium nitrate. Magnesium still +2. We know that nitrate's -1, and if you forget that, the hydrogen is always +1, so there's 1 hydrogen here, it's a total +1. Nitrate's got to be a -1, so we're also going to need 2 of those. And you can look at your chart, but that will be aqueous as well. Now we have to balance it. We know that there's 2 nitrates over here and only 1 here, so we are going to say 2 of these react. We also look and say we've got 2 oxygens here outside of that nitrate, and we only have 1 on this side. You're going to need a 2 here. You can write it all out. That'll be helpful, but that's not the point of this video, so I'm not going to do it right now. But that should be balanced because we've got 2 hydrogens, 4 hydrogens here, 4 hydrogens there, 2 nitrates, 1 magnesium, 1 magnesium, 2 oxygens, and 2 oxygens here as well. So it's asking how many moles of magnesium hydroxide are needed to neutralize 1 mole of acid. So just like last time, you're going to have that 1 mole of HNO3. You're going to multiply by the ratio from our coefficients here. No, it's 2 moles of HNO3. Sorry, I should write that down. To every 1 mole of magnesium hydroxide, which will give us 0.5 moles of magnesium hydroxide. Okay. As always, everyone, good luck and have fun.